Hello. So in this session of Git and GitHub, we'll start with the first thing is that why do we need version control? That's the first point that I want to discuss. See, when we are developing a software, we don't get it right in the first go, right? We'll make some mistakes and then we'll modify. That's a very nature of developing writing code is that you write some code, then there are some mistakes, you fix them, or there may be some enhancements that you can make. So these two ideas are very central to version control. One is bugs and features. Bugs are mistakes in your code. Let's say you expect something to behave in a certain way and it does not behave in that way. That is a bug. For example, you click a button, you expect it to call some API, get some data and display it, and now in the pipeline, in the flow, something gets wrong. You make some typing mistake, or maybe some logical error, some kind of error you are making, and that thing is not functioning as expected. Bugs can arise due to various reasons, but that is a bug. And a feature is that you add some enhancement to your software, you make your software better, you add some new feature. So these two terms very popular terms. But now version control means you one thing is that you can create different files, right? So you can open your terminal and let's say this is hello, am I audible everyone? Just once someone respond please. Is everything clearly visible and audible?
Yeah.
Okay.
You are audible.
So the thing is that suppose I am working on some file. Let's say first of all let me make some temporary directory. Temp get. I'll be working here now. So for example, I'm working on some file. So let's say I can the micro is my editor. It's just like Vim you have, but like other editors, micro is just an editor. So let's say I edit some work. So this is my work.txt. So I write some lines of code. Let's say I line. This is my version 1. Then if I modify it, see what is the meaning of version control? You are keeping the previous versions also. I want to keep my previous version saved. For one line we don't need, but for 1,000 line code, now suppose your code is not working properly, you want to change a lot of lines, so you will never risk losing your previous version. You will obviously save your previous version, then create a new file and work on it. That's a standard way. But thing is that if I store this multiple files, it will take so much space. So if I have one file with let's say 100 lines of code, then another file I create and again 100 lines of code, but only 2 lines have changed, so I'm storing 2 files, like so much memory is being wasted. And again working with them is very difficult. If I want to manually name the files work1.txt, work2.txt, work3.txt, I have to create multiple files. And when it goes in a large scale, when you're developing with multiple people, this kind of management becomes very difficult. That's where a version control system comes into play. Now I want to give a special mention to Linus Torvalds. I hope most people, some people have actually heard his name. He is the father of Linux. From his name only, like Linux has come, and he started that the development of the kernel from age 13. Like at that time, that was only the normal thing. Like that time, they did not have all these things. Like that was a start. Like he probably used C or assembly language to start code the. I don't know. I forgot. I read somewhere like he used some language to start writing. Now Linux was for his personal use. That time Windows was already there. Now Windows was paid and buggy and a lot of issues were there, and there has been a long history of fight between Linux and Windows. Like Windows have like done very malicious, like very what to say. Like Windows was very jealous of Linux. Windows did many kind of advertisements that were not good. So there's an interesting history of all this, the Windows versus Linux controversies and all. Like there's a good amount of excitement among developers who are in this community. Now, thing is that when Linus Torvald was developing Linux, the kernel, the operating system actually, then what happened is that he, when more people wanted to join him, and the first issue he faced is that how do I manage the versions? How do I allow multiple people to work together on the same project? That led him to create the tool called Git. So Linus Torvalds' biggest contributions are Linux and Git. Git is industry standard. Like any company you go, they'll probably be using it. Like 99% companies are using Git. There are other version control tools also. Like SVN is there. There is an old version control. Mercurial is there. Some these are also version controls, but they have some fundamental differences. In this session, we are not going to discuss them. I also don't know them in proper. Like I forgot. I watched maybe some in past, but I have no clear idea about how those systems work. But for our work, Git is just enough because Git is used by 99% of the industry. Only in very specific niche cases you would need some other kind of tool. Now history of GitHub is that GitHub started as an independent company. What is Git and what is GitHub? Like what is the difference between these two things? Git is just a command. Like you have your ls command, right? Ls command helps you do something. You have grep command, it helps you do something. Every command helps you do something. But Git is a program. Git is a tool that helps you version control your files locally. So if I just look at this, I have Git already installed. I will after this I will discuss how to install Git. Installation of Git is very simple, but only thing is that the password manager or credential manager system, that is little like when you are authenticating yourself, you need the multiple authentication methods are there. We have to use some secure method and like probably do the setup of that. That's only little bit tricky part. Tricky part means it varies from one OS to another. But other than that, every command, everything is just the same in Mac, in Windows, and Linux. Everywhere is just the same. So history of GitHub is that it was an independent company, but later Microsoft acquired it. Microsoft acquired a lot of things. Like Microsoft is a major player. You see Azure, like just like you have Google Cloud Platform that is called GCP or AWS, Amazon Web Services. Similarly, Microsoft has their Azure, that's their cloud platform. Now, what Microsoft does is basically they own a lot of things. Like for example, VS Code. VS Code is also owned by Microsoft. Like it was an open source project initially, but Microsoft acquired it, and Microsoft version of VS Code is proprietary. There is an open source version also parallelly. So Microsoft controls most of the development workflow. Again, Windows is the most popular operating system. Again, it's by Microsoft. No, Microsoft is a like dominating position. Please. Oh. So what? Yeah. So I discussed about Git and now what is GitHub? GitHub is a platform where you upload your code and all. So that's a fundamental difference between Git and GitHub. Git is the tool that helps you version control. Like Git will handle the files. Git is a program that will read your files and it will automatically create versions. Now in Git, there is a thing called commit. Commit means it's a stage in your software. Like you want to save a particular stage, a particular state of your file. That's a commit. You want to save it. You want to give some name to it, some comments to it, and you save it. That's a commit. And we will discuss more about commits later on. But thing is that I was discussing GitHub. Now GitHub has become a social media platform also. In GitHub, so if I look at GitHub, if I open github.com, so here you can see this a feed comes like just like in Facebook you have some people I follow. So these are the feed of those people. So these are the feed. Like I can see that suppose I have followed Ramnes, this person, and this person starred 4 repositories. Now starting is nothing like in Facebook you have a like, right? Similar to starting, you like something and you like this is so many. GitHub actually revolutionized the entire industry by providing open source code. Like GitHub is very crucial for the open source ecosystem. Now when you open your GitHub, the interface is something like this. Over here in the left, you will have your repositories listed. You will whatever repositories you created, all these repositories will be listed over here in the left. Now, you can create a new repository by clicking here. If you are part of organizations, you can switch your organization. So first of all, let me go through the GitHub UI. It may look little complex at first, but things that it's just like any other platform. Once you use it for a few days, you will get very familiar with it. Like just like Discord. When we started using Discord, it looked a little bit uncomfortable, but once you use it for a few days, few weeks maybe, then it will be very easy. So here is a search bar. You can search your repositories or anything you can search, like anything. Now in the search, they have some advanced flags also, like by advanced search techniques are there. So here, yeah, there are a lot of new things like code spaces, marketplaces are relatively new things, but original things are issues and pull requests that we will discuss. Now let's say, let me go to this repository. Let me take the example of a repository and let me discuss what are the components of a repository. So this repository has opened. So you see this is the username. It can be a user or an organization. So if I open this in new tab, you can see pingcap. This thing is an organization. So the URL looks like this, github.com/the organization. So you can create an organization and here you see a verified tag is there. Just like in Twitter, just Umesh has joined. Okay, great. Okay, fine. So just like in Twitter, you have your blue ticks, right? Hello, is there any background noise coming? Vishwajit, hello.
Just a little.
Just a
Not
little, yeah.
much.
In my surrounding room, people are shouting. Okay, fine. Is my voice clearly audible? Like, is my audio quality?
Yeah.
Yeah, thanks.
You
Now
So,
your video is on, you can turn it off.
what happened?
Video is on.
Okay, my video is on, but it's black. Okay, now I think it's fine. Thanks. Is it okay now? Like, is the video gone?
yeah, the video.
Okay.
Yeah.
So now, as I was discussing, let's say in Twitter you have blue tick account. Similarly, in GitHub you can have a verified profile, a verified. You can follow organizations. This feature was not there. Oh, who is joining, man? I will deny entry because I cannot handle so much people. This is just a trial session. Okay, and please don't share links because this is not an official session. Like I'm just recording for personal use. So as I was discussing, you can see this thing. There are a lot of options in this UI. So I'll go through them one by one. So here you have the about section. Every repository has an about section. You can write what your repository is about, and you should write it properly because when someone searches in Google, this thing will actually help in the search engine optimization, the SEO. So if you want your project to be discovered, that's very important. Now this is readme.md. This is the most important part of your project. Because if you don't write what is your project about, if you don't explain it, then what's the use? Then you, like, people will not be able to know. There are a lot of repositories with code, just code. But thing is that you should probably write a readme. It will take maybe 30 minutes, but that's a good investment, I think. This readme.md, this is rendered. This, you are seeing HTML over here actually, but this is actually written in Markdown. Now, writing Markdown is very simple. If I want to see this file, let me open this file. Let me open the readme.md file. These are all the files. Now, if I click on raw, I can see the actual raw thing. Yeah, this is the actual raw thing. Now you can see some inside Markdown, you can write HTML. So h1 tag is nothing but your heading, just heading 1. A tag is just your image and you're putting a link. So now this is the fun of Markdown. You do double hashtag, this is just a heading. Like single hashtag is, so let me show what Markdown is about. Now writing Markdown is very, very simple. In just 2-3 minutes, I will go through Markdown. It will not be an issue. So I'll show some important things about Markdown. So if I, okay, where is it? Scratch. So if I discuss about Markdown, so here we go. So you write a heading by single hash, please. You write a heading by single hashtag and you just then write your like heading 1. So you can have subheading levels. This is heading 2. Actually, this is not a part of GitHub. Like this is just an extra thing, but this is very important. In GitHub, whatever you write in Markdown. Markdown is a standard across all repositories. So you have heading 1, heading 2 like this. So this is like h1 tag in HTML, h2 tag in HTML, and so on. And you can put a link. The most important thing is putting a link. So if I just put link, this is a link. Let's say this is a link text, and I'll just put this brackets around it, and I'll put this brackets, and I'll just put the link. So I want to redirect to, let's say, what, google.com. So this is the link. Now if I render this, if I open the view, so this will be a link. I can click this and it will point to google.com. Next thing is that image. How do I put image? I put an exclamation mark, I put this brackets, and then I put the link. So here I will put the alt text. Alt text means alternative text. If the image is not being able to render, then we'll show this alt text. So you just write the name of the image. Let's say cat. Now after that, over here I will put the link to the image. Let's say, let me open browser and let me just search cat images. So if I get a cat image, right? The internet is slow, man. So bad. I have to wait after Google search. This is the most horrible part of. If you have to wait after you click enter. If I copy the image address and if I just paste here, that's it. Oh baba, what is this, man? This will work. This link is a very dirty link. This has so much referral and all. Man, this has so much things. Like this is some code has been put there. But thing is that the link will work. We can actually clean this link. If I open this in new tab and okay, this is pixels, right? I'll leave it. It will be a waste of time. So that was my point that I was saying. You can put all these things that you can put. And now you can put bold. So if I have bold and I just put this double stars around it. So this is very much similar to Discord and all. Many other platforms have been inspired by Markdown. So that was my point. And here I go. If I see this, this is the lists. Basically you have inside list, like in one list, and you just put some indentation, you put some tab, and then you write another list. So these are like nested lists, what you can say. So these are nested lists. So this thing is discussing about, this is a particular project, there's GPT powered data exploration, blah blah blah. So they have put the sponsors, they put the development. Now this part is very important, like how to set up the development, how to download this code, what packages to install, and how to run it. So those kind of things, links are given over here. So ideally you should put some images over here so that people can know what it is about. And this is some important links on the top they have given. This is how we construct a readme. Now let us come back to this code part and let us, these are all different files are there. I'll discuss them later on. Now this is a particular project. You can see what languages have been used. In the languages tab, you can see this is the project primarily in TypeScript. They're using Jupyter Notebook for some data exploration, maybe some HTML, CSS, some JavaScript is there. So if you're not familiar with TypeScript is just JavaScript. It's exactly same as JavaScript, but thing is that there are type stubs. Type stubs means you specify the type. Now in C, we have compulsorily we have to specify the type. I cannot just say a variable. I have to write int then variable. In Matpot, let's say in MATLAB, you don't have to write variables. Like you don't have to write the data type. It's not compulsory. It's dynamically typed. Python is dynamically typed. JavaScript is dynamically typed, but TypeScript is a modified version of JavaScript. Actually, TypeScript code compiles to JavaScript. That's the fun thing about it. So here you have all this stuff, and here you can see the contributors. This is the most important thing. So when you commit from your account in any repository, so this organization can be anything. It can be another person's account also. You can see what are the contributions. The internet is slow, huh? So you can see the history of this project. It's when it started till when it's active. and you can see the commit frequency of different people, in which month they committed, how many lines they added, how many lines. This green color thing is the how many lines they added. This just a second, am I audible to everyone? Everyone please confirm, please. Is the session going
Yeah,
fine?
yeah, you are right.
Okay, okay.
You're audible.
If I'm getting slow or if I'm getting too fast, you can just always tell me. Like, I'm doing this kind of sessions very freshly, so it will be very helpful if you give me feedback about the pace of the session, about what to go into detail. Any question you can ask. So here you can see the green color thing is the number of lines added, and this red color thing is the number of lines removed. So here you go on, you can see all the people. So obviously it's sorted. The most highest contributor. See, highest contributor may not be the most valuable contributor. Sometimes a lot of configuration files are there in a project. So if you write those configuration files or those kind of files, so your number of commits may be more, but you may not be a important contributor. So it's a thing like number of lines of commit does not is not only parameter to judge who has contributed more. This is just a thing. Now here you can see a lot of different things. Like you can click on the dependency graph. Now, these are all features that GitHub provides. GitHub actually has a huge database to understand. It can parse. So different languages have different ways to specify what are the packages I require. So till now, if you talk about C, most people are just working with the standard library. Now beyond the standard library, there are libraries and code written by other people. So you can install them and you can use their code. You don't have to do a lot of hard work. For example, just let me show an example. Today I was just trying to implement this thing in Python, the hexagon. Thing is that it's impossible for me to implement it from scratch. If I don't have a plotting library, it will be impossible. I need something to that will handle the screen and all. So if you look at this code, I'm using some library called matplotlib.pyplot. This is very similar to like what you have in MATLAB. And this is the exactly same code what I wrote in MATLAB. I just exactly copy pasted, like I Pythonified it. I ported it to Python. So here you have the code. So this matplotlib is a library, external library. Again, you have NumPy. NumPy is for handling numbers. It has a lot of advanced functions. So it's impossible to remember. So when you need something, you just Google search or you watch some video. I also don't know these libraries. Like I have zero idea about these libraries. Today I just Google search and found them. And thing is that for the range, normal range function does not work in like that cannot handle float in Python. So we use the np.a range. So this can handle floating point value. So it starts from 0, it goes to 2 pi, and the step is pi by 3. So increments like 60-degree angles. So at 60-degree angles, these points are plotted, and the plot function, this plot function will actually join those points. So you pass the list of points, pass a list of x points and pass a list of y points, and plot will plot. So here is it. Now this is the for plotting multiple hexagons. So what we are doing is shifting the origins and plotting. So very importantly, we are dependent on so much other libraries. Now this is a Jupyter notebook. It's inside a platform. No, these are all just platforms. It may sound like what is the new term, but thing is that is nothing. This is a platform that is providing all these libraries are pre-installed. I don't need to install. But in my local, why I gave the example, the purpose of me giving the example is that in this Jovian, what we have is that these libraries are pre-installed. Jovian is popularly used for data science purposes, and it's like this is a startup by some IIT Delhi and IIT Bombay guys, and they worked in Google and some other big Twitter or some big companies, and now they opened this startup for data science and all this stuff. So in this platform, you can write Python code and you don't need to worry about installing this kind of libraries. So today I was trying to work on my local machine, but I was facing some errors. Some libraries not supported this and that. It's a lot of errors. Then I just use this. Now the point is that when you are using external libraries, my point is that when you are using external libraries, you have to specify them in some kind of requirements.txt file. Different languages, different like packages or frameworks have different ways of specifying that. So you are dependent on some other libraries. You have to specify them. So these are the dependencies. So this particular project depends on these other projects. For example, when we are using, let's say, Godot. Now Godot is a engine, but inside Godot actually you can use other people's code. You can install some other people's code and like use some other Godot projects. There are a lot of Godot libraries are there to handle some basic stuff. You don't have to code everything from scratch. You can just install them and use them. So here actually, as you can see, this project is in actually your TypeScript. Now I don't know TypeScript. I have not yet done any project in TypeScript, but I have heard this package.json. This is actually specifying your, I think, dependencies. I'm not sure. No, sorry. This package.json file specifies what is dependent on. Similarly, if you see in your Godot also, you will see some file is there that specifies certain configuration stuff. So let me see, what is that? So these are different files. Don't get confused by these files. There may be so many files, but most of the files are not code. Actually over here, I think the code inside web. I'm not sure. Let me check. No, it's I think inside web, inside src. I think there is the actual code. Now it's a very huge thing, not a small 1% activity. It's a big project. You're seeing so many packages and all. So this file, a lot of files are not actually code files. A lot of files are just configuration files. So if you open some kind of, let's say this is my project, this is a very old project which I started in 12th standard, and now this has crossed, like, got a lot of stars. Now here I created some things with Canva and all. This is how we can create some screenshots are there, some links are there, and blah blah blah. Now over here, these files are not actually code. All these files that you're seeing, this serve some purpose. So as I have encountered the need to do something, which is Google search, and you figure out. Now we will discuss about certain important files like git, ignore, and license. We will need those files in our project. Other than that, this Docker, blah blah blah, a lot of other things we don't need for our game jam. We will need this very importantly, this license file and the git ignore file. The actual code is only in this folder, so you should not get confused by so many files in a project. So that was the point I made. Now you got like introduced to the GitHub interface. Now about Git and GitHub alternatives, there is a GitHub alternative called Bitbucket. So they also you can host Git repositories. It's a platform like GitHub, but they also use Git. They also use the Git's version control. This is another platform. Now what we have, another thing is that there is another thing called GitLab. This is a completely open source. Okay, now one term you may encounter. What is DevOps? What is DevOps? It's operations after development. You write some code and then there is a production environment. In the server it's running. You write some web application, the server is running. But before that it needs to be tested. There's a life cycle of the software development. There's certain process that needs to be followed. So all those things actually comes under DevOps. Like inside DevOps, what is handled? Automated testing is handled. Automated deployment to some particular server is handled. Deployment means you just run it on a server. You write a code and then needs to constantly run on a server. Let's say this website is coming. Something is constantly running in the server. When I'm doing a request, it's responding with some data. When I will sign in, it will check whether my credential is correct or not, and then it will respond with my data. So that is it. So I have covered the history of GitHub a little bit, like Git and GitHub alternatives are covered. And about the need to learn GitHub, I don't think I need to say the need to learn GitHub because it's the industry standard currently. In future it may change, but for now GitHub is used by almost all companies. Now let me show you, like, where is Python hosted, like Python source code. Some repositories are not hosted in GitHub. Like for example, what to say, your let's say Linux is not hosted on GitHub. It's hosted on GitHub, but they actually develop through, they have their own Git server. They don't use GitHub, they have their own Git server. So this GitHub is just a Git server. Now what is a Git server? Currently I don't have my pen set up properly. I cannot use the pen, but thing is that you have all seen the client server architecture. There's a client and there's a server. So now imagine multiple clients, multiple computers are there, and now there is one central server. Now in the central server the code is stored. Now everybody will push to the central server. I write some code, I will push to the central server. Another person writes some code, that person will also push to the central server. That is the idea. Now if I search Python here, I will see the Python repository. So it's by Python Software Foundation, PSF. There's a lot of other repositories related to Python. And on search is not coming on top. Just a second. Python PSF. Hopefully we'll get, yeah. This is the Python's official thing. So this is the official verified organization Python, and they have this thing CPython. This is the actual interpreter for the Python language, and it's written in C and Python. Like a lot of libraries are written in Python, but the actual interpreter is written in C. And you can see some other type of files are also there. Some C++, some HTML, some other things are there. So this is it. Now let's move to the next point, that is how to install GitHub. Now, no, sorry, not GitHub. Install Git. Now you have a GitHub desktop app. That's not what I'm talking about. GitHub desktop is a different app. That's just a similar interface as the website. You can just use the website for all practical purposes. Now, GitHub desktop offers some conveniences. That's it. Like it's again the GitHub. You can see your this and that, like repositories and everything. But what we need is that Git command line. It should be installed in a command line so that we can use it. Now, how to install Git? How to install Git in Windows? So you will get a lot of tutorials. There are different package managers in Windows. Like for example, Chocolatey is, I think, they're in Windows. So for example, for Ubuntu and Mac, it's pre-installed. If you are have dual boot setup, then on Ubuntu you can directly use Git without any issue. So if you're on Mac, then Brew package manager is very popular. That's Brew install Git, one line. That's it, done. On Ubuntu, it's just pre-installed. You just need to, if by chance it's not pre-installed, then you just need to do sudo oh, what's happening, sudo apt get install Git. So I already have this package. Git is already installed to the newest version, so I don't need to install it. So once you have installed Git, you will get this thing. Now in Windows, it might be a little tricky to install Git. I'm not sure about Windows, I hope it will be pretty. If you are using WSL, Windows Subsystem for Linux, their Git is again pre-installed. So here is Git for Windows. So here is a Git for Windows installer, and the official website of Git is that Git SCM. So this is Source Control Manager, something like that. So this is the actual official website of Git. This is the actual Git team, and you see what companies are using GitHub. All the big companies you see, and GNOME is very popular. GNOME is a desktop environment created for your Linux. This is Android, and this is Postgre. Postgre is another database similar to MySQL. It's very popular to use. Ruby on Rails, it's a framework. Now it's slowly getting less popular, but yeah, it's there. Qt is for creating desktop interfaces, for creating desktop apps. These are very important. Like Qt plays a very important role in the industry. Then Eclipse, a very popular code editor. I don't know what this can. Oh, this is Perl. Perl is another language. So you see all the big companies and projects that are using Git. It's a very large number of people who use Git. Now here from the official Git website, you will get everything. You will get all documentation and everything, and that's it. Now for installation, it will vary a little bit by system to system. So you can watch a video on how to install Git in Windows, and you will get that. For Mac and Linux, you don't need to. Now, first thing is that how do we use Git to track files? Now we come with the actual thing. Let's now discuss how to use Git locally. How to use Git locally. That's what I want to discuss now. So I have opened this thing, my terminal. Once you have your Git installed, what I want you to do is that you can follow along with me. If anyone wants to follow along with me, I can wait for some time for you to install Git. If anyone wants to follow along, so do I need to wait? Someone joined. Hello, am I audible?
Yeah, you are audible.
Okay. Does anyone want to follow along the commands with me? Then I can wait for you to install Git. Okay, no response. Okay, fine. So let me start with this. So to create a Git repository. What is a repository? Repository is just a term for the folder, the main folder, the parent folder inside which all the files will be tracked. So repository means the root folder. So the shorthand for repository is repo. You will hear this term very commonly. Repo. Repo means the repository. So what is a repository? Like github.com/something. That is a repository basically. So if I open this, for example, this is a repository. This thing is a repository. This OS inside. This is a repository, and this is the owner of PingCap. PingCap is the owner of the repository. This is a repository having all the files. Now, one folder is there inside the repository. When you are running it locally, there is one folder called .git. Anything that starts with dot is actually hidden. In Windows, it's not hidden. In Windows, it's very bad. But in Mac or Ubuntu, in Unix-based systems, it's hidden. So all the dot files are hidden. So if I go to my home directory, and if I just do a ls, I'll get some folders. But if I do ls -a, I'll see all the dot files. So these are all the dot files that has been generated by different programs. Different programs use dot files. They're not visible by default. So in the this Explorer also, the dot files are not visible. But if I do Control H, then I can see the dot files. So that is the point. Now what we have is that so thing is that there is a folder called .git created. So if I do git init, this is the first step to create a GitHub repository locally. Now this is not there in GitHub. This is just a local Git repository. And locally I can track the changes. So if I run the git init command, it will create a GitHub repository. Now it will show some warnings or some hint and blah blah blah. You can do this in many other ways also, but I'm trying to keep it as simple as possible. While you are doing git init, you can pass some additional options to configure how the repository will be created, blah blah blah. Now the default branch is master, but now the convention is that it's not mastered anymore. Like the main, what is a branch? Let me talk about branch. Branch is just one line of code. Not line of code. Actually, it's one, what to say. Let me show you one image. It will be absolutely clear. Just a second. If I just show github.com, branches are like you branch out. Like, yeah, this is a concept of branch. One code is going on, and you see one branch comes out. That is what I mean by branch. So, for example, branches are meant to be merged back to the original branch. So there is some code. There is a 100-line C code. Imagine there is a 100-line C code. Now you intend to add. Let's say you intend to change it. Like everything. For example, let me take a very simple example. In your C code, you have written everything in main. You have written all your functionality within main. But now you want to make individual functions for every functionality. That is the change that you want to do. So what you can do is that instead of corrupting the main branch, you can create a new branch. That the new branch will come out from the main branch. So when you create a new branch, it will have exactly same code as your main branch. Now you can modify that branch. After the modification, you can merge that branch back to main. So main will again get updated. So what happens is that different people can work on different things at the same time. So some person is working on some particular file, another person is working on another file. So every person can create their own branches. They can branch out. Again, when the work is done, they can again merge back. They can merge back to the main branch. So main branch is what that will be released. That will be released for the users to use. Now there can be a dev branch. The very popularly used convention is use a dev branch, dev. That is under development. In large projects, there is a lot of branches like alpha, beta, alpha release, blah blah blah. Lot of in terms of software release, these terms are very common, and different companies, different projects have different ways of naming their branches. We can use any convention that we love. The thing is that the team members should know what convention we are using. So all the team members should use the same convention. That's it. But different projects across the world, different companies across the world use different conventions. Now here, if I in my terminal, I have this ZSH shell, just like bash. ZSH is another shell. Now, and I have something called P10K. I forgot the name. That configures the color and all. So over here, it's showing me master, and the cross sign is that it's not committed, like it's not updated. So I think we will not discuss this in details for now. For now, actually, this cross sign actually means that there are changes that has not yet been committed. Okay, so if I just do git status is a very important command. First command we learned is git init. Second command is git status. By the status command, I can see what is the status of this repository. So if I click enter, so this file is untracked. So I need to first start tracking a file. If I don't track a file, Git will not track the changes. So these are untracked files. Now, first thing, it shows that me on which branch I am. There can be 10, 20, 100,000 branches, but I am on the branch master. So it will show the name of the branch. Next thing is that it is showing me no commits. I have not committed anything. Next thing is that untracked files. So these are the untracked files. So if I want to add these files for tracking, so I can just do git add. Then I can write the file name. I can do work.txt. Or there is another thing. I can just do dot. Dot is a wildcard. Dot means everything. When you click to dot, it means everything in this folder will be added. But we will have something called git ignore. When we ignore certain files, those will not be added later on. But for now, there is no git ignore. I can just do git add dot. This will add all the files. Now, if I do git status again, you see that this has turned green. So it is showing that there is a new file that is being tracked. That is work.txt. Now this change has not yet been committed. So this is showing me under changes to be committed. And understand, this entire thing is on my local computer. I can use Git on my local computer without an issue. And but thing is that when we want to collaborate with multiple people, then we need a Git server, some central server that will host the repository, that will have the entire code, that will track everything. So what happens is that Git is a distributed version control system. What do you mean by distributed? It's that there is obviously one central repository, but every person will copy to their own computer. People will not be working on the central repository. Everybody will not try to modify the central code. No, the central code is there for some platform, is there for collaboration purpose. We need a hub, we need a center, we need but now everybody will copy. So when I work on some remote repository, I need to clone it. Clone is a very common term. It means that just copy, exact copy. So I need to clone a repository exactly to my own local machine. Then I can work on it. So every user who wants to work, just a second, bro, just a second. As I was talking about the clone thing, we need to clone it. But see, this is a repository that is locally created. I did not clone from somebody else. I'll show how we can clone and blah blah blah, all the stuff. Now what we have here is a new file. So I can commit this file by git commit. Now I can put a commit message just like this. I can just do -m. This -m is basically nothing but a flag. It's just an argument, you can say. Like in a function, there can be multiple arguments like x, y. Let's say you have a function that adds, function add, that takes two parameters x and y, and it adds x and y. Similarly, a command, when you're using a command, so this -m is a flag, and some flags can accept some values. So after m, I can put a string, my commit message. So I can write, this is my first commit. I can write this, and I can click enter. So you can see that one file changed and one insertion. There has been no deletions. I have not deleted any lines. So insertion means I have just added lines. Now, there are some create modes. I am not sure about this. You can look that up. There are different modes, and different modes have different numbers and blah blah blah. It will show how many files were changed. And this is the now thing is that I can run git status again, and I can see nothing to commit. Working tree clean. This is a very important thing. Working tree means it's basically a lot of things are there in Git. Like you can create multiple branches, you can stash something. We'll discuss that later. But it's kind of works in a tree data structure. So Git internally uses the tree data structure. I'm not fully clear about how it uses a tree data structure. I'm not fully clear about that. I need to look that up. That's a good question I asked myself. But thing is that I'm not sure about that for now. I'm currently on branch master. Now let us try to see this cross sign has also disappeared. There was a cross sign here. Now it has disappeared. Now what we can do is that we can do git log. This command will show the history. So you can see the author. The author is there. Now where it was committed in the master. Now head means the latest commit. That's a head. Okay. It's kind of like a stack. One commit on top of that, another commit on top of that, another topic. Okay. It's like a stack data structure. Stack means like a stack of plates. So this is head means the topmost commit. The latest commit is the head. And here you have the author name. You have the date time is there, and then you have the commit message. That's it. So if I do after the, I can just do Q. I can press Q on my keyboard. That will exit that screen. So this was git log. So we have discussed the basic git commands. That is git init to initialize to create a new repository. I don't need to do git init every time. For example, if I go back to my parent folder, okay, now if I go to the temp git, I already have git here. I can just type git status. It will show me that I am in a git repository on branch master. Now let me show you. Suppose if I am on a folder that is not a git repository. Well, am I audible? Just everyone just confirm.
Yeah, you are audible.
So for example, if I am not on a GitHub repository, a Git repository, then what will happen? Let's say I create a folder. Okay, by the way, this MCD, there is nothing called MCD in Linux. I just created a function for my convenience. MCD actually what it does is that it creates a new directory and then it moves into it. So if I do MCD, it types some name, let's say I type a name. So what it will do is that it will create this folder random, and now it has moved. I have CD into random. So it's not a Git repository. If I do git status over here, it will show me this is not a Git repository. Okay, because it does not contain .git. That's it. So now .git is a folder. Now I'll show what is contained in .git. It's not for a human understanding, but let me actually open this in my file manager. And here what you can see is that, so you just see the work.txt file. But if I show the hidden files, I'll see a .git folder. Now, this .git folder has so many files. These files are used by Git. And this .git folder is not visible in GitHub. When you upload this to GitHub, these things will not be visible. Okay. These things, GitHub will use this data to show relevant information. Now, if I go to GitHub, let me show. If I go to github.com, okay, let me go from here. Let me go from this. Over here, if I click on this thing, commits, this is the history of commits. 1764 commits, like 1764 commits have been done. And this is the last commit 4 hours ago. And this tick you are seeing, they have set up some checks. They have set up some CI/CD. CI/CD stands for continuous integration, continuous deployment. That is nothing but basically when you push the code, it will automatically run some tests. And those tests are also like another piece of code. Those piece of code will run on this. So if I click on this commits, I can see the entire history. Now there are certain things. You can see this thing. This is the commit details. You can copy this SHA. This is actually unique code. And there are cryptography algorithms and all. I'm not fully clear about that. But here we have, this is the commit message. And if I click on these 3 dots, this commit has some description. You can add as many lines of description as you want, but the commit message is limited by length. You cannot. Now you can see the branches. This project has so many branches because this is, as you can see, it's a large project by a lot of people. So they have different branches. You can explore all these branches. And if you click on a particular branch, you will go into that branch. Now this is the entire history. So you can see February 2, 2023. These are the changes that were made. So if I click on particular commit, I can see what changes were made. This is in red. You can see this line was deleted and these lines were added. So every commit is just a combination of deletion and addition. Some things were deleted, some things were added. So this is what we have. Now in GitHub, as I said, it's a social platform. So if you want to talk about a particular, you want to discuss about particular commit, you can actually write a comment and you can tag people. You can just use the hash @ and you can actually use. Actually, I'm not, person's name is not saved. Like when I will have a first interaction, after that it will do autocomplete for me. So you can actually, when you're working with a particular project, there are some particular people who have worked on this project. For example, if I just do @MAN, it's not showing autocomplete. I don't know why, but actually it shows autocomplete. When you start typing @, it will show you the person's suggestions will come actually. So this is one view, this is one view, split view. Like in the left you are seeing the original file, in the right you are seeing the new file. These are the changes. The red shows what is deleted and green is what's. Now you have a unified view also. This is another way of viewing changes. It's a unified view. You can see in the same file, instead of left right, in the same file you are the changes are shown. And you can also have the split view. Now that is it. Now every commit is a particular stage. If I want, I can use this particular state. I can use this particular state. If I click on this, I can click on browse files over here, and I will go to this repository, is this state. So this is the state of the repository. See this thing in the slug, this is called a slug. Something.com is the domain name. After that, whatever you have is a slug. So in this slug you have this entire thing. This is the particular commit hash. So this is a unique thing that is generated for a commit. No commit will have the same thing. A hash function is basically something that generates a new thing. Like, hash maps are a data structure. You can store some key value pairs. So this hash is generated from the code. Some particular hashing algorithm will be used. I think that is SHA, secure hashing algorithm. These are some things that we will have in future. I don't know anything about how they work, but these are just names that I have heard. So this particular link is actually showing me that particular state. I am in this particular commit. So I can see, I can view what was there in this particular state. So I can view and I can like see what state it was in. And there are certain things like you can watch a repository if you want to receive notifications. If you have the GitHub mobile app, or if you just want to receive notifications in the notifications panel, you can fork a repository. You can start a repository. Start, as I already said, is just like following some. It's just like liking a YouTube video. Just to start it. That means you show appreciation for the person's work. And fork means you create a copy of this project in your own account. If I fork, then this OS inside will come to my own repository. It will come arnik/OS inside. So it will copy will be created. After that, I can make some changes, and then I can do a pull request. What is a pull request? When I make some changes, it can be better said as merge request. So I make some changes and I tell the original maintainer to merge it to the actual code. That is nothing but a pull request. Now, as we have discussed about the GitHub interface, we have discussed a lot. Now, Git init has discussed, status have discussed, add have discussed, commit have discussed. Now let us talk about the git diff command. So if I just run git diff, okay, what's happening? Just a second. Git diff work. Actually, no diff is there currently. We need to add some more comments. Okay, now let me change something. Let me go to this micro work dot. Let me open this file and let me add a new line to here. So this is my hello2. This is a new line that I've added. I am saving this file and exiting. Now you again see the cross. You again see the cross in my terminal prompt. You can see the cross. If I run git status, what you will see? Git status, you will see this file has been modified. So if I do git diff, I hope, yeah. So this is another format, like you see plus plus minus minus. So this line has been added, plus empty. Just a plus means it's an empty line. I added this new line, and plus hello2. That means I've added this words. So if I delete something, it will be shown in red. So this is a unified view. There are two views, a split view and unified view. In the split view, you have the left and the right. In a unified view, it's shown in the same lines. So if I exit this now, the git diff comment. Now, if I want to commit this, git commit, see this file has already been added. Git is tracking these files. I don't need to run the git add command again. Initially, I need to add the git add command. When I create a new file, I need to add that file to the tracking list. But once it has been tracked, I don't need to do git add every time. It will be tracked by GitHub. In the git status, I can see it. No, not GitHub. GitHub is different. Sorry. So I do git commit. Now I do -m, and here I can make some changes done. So in a project, you should write meaningful commits. So now, okay, just a second. This changes has not been staged. Oh, just sorry. I need to add these changes. The file is already being tracked so that I can see this. I don't need to add the file, but thing is that I need to add these changes. So if I open this thing in VS Code, let me show this, because most of the people work in VS Code. In VS Code, this tab panel is there for your source control. This thing, this symbol is there for this. You see the branching symbol is there. So here you can see the changes. Here you can see the changes. See, these lines have been added. VS Code automatically shows you all this stuff. So you can click on the plus button to stage the changes. Now, what is the concept of staging? Staging means that I put them on a stage. It's just a pipeline, you can say. Commit means the thappa. Like commit means it has been committed, done. Stage means before I commit, I put it on a stage and then I commit. It's just a layered process. Now, as you work with Git, you will get very familiar with the process of staging and then committing. Initially, just a bit awkward. Initially, it's like weird. But thing is that once you work with Git, it will be very familiar. Like you just gasho in Bengali say gasho. It will be just, you will ignore it. This kind of things. So staging is just it's putting on. I don't have a pen right now. Otherwise, I could have like done it a little better. Stage, if I just do add, click on the plus button, this is the staged changes, and these are the, there can be more changes, those are unstaged. So let me add some more files. Let's say hello.c. So if I go to this, I have this unstaged changes. These are the changes, these are the staged changes. These are two categories. Now you see u, what is the meaning of u? U means untracked, m means modified. So when I click commit, this unstaged changes, it will not be committed. So let's say what is the benefit of this staged and unstaged changes? That will be very clear once you. What's the benefit of this staged and unstaged changes? That will be very clear when you work on multiple changes in a file. So here in the staged changes, like let's say you have changed 10 files. Now you want to commit them one by one. You don't want to commit all 10 changes at the same go. Let's say while working, you will not be thinking about committing every time. You have worked on multiple files, you have changed a lot of things. Now you will be committing one by one. That's the point. Now here I have in my stage changes, this is the work.txt. If I click commit, this unstaged changes will not come. If I click commit, okay, now thing is that I have not written any message here. So this in my editor, this page will open automatically. This will pop up. I need to put a message. Without a message, it cannot be committed. So let me write some, this is change work dot text. This is the message that I can write. If I save this file, oh, I exited that accidentally. So if I open VS Code again, okay, yeah, I just need to close this file, then it will get committed. So if I look at this, what happened? Did not get, what happened? Some error has occurred. Sorry for that. I need to write the commit message, and here let's say I have hello and I just commit it. So this change will be committed, and this is untracked yet. If I do add it, this will be added. A stands for added. So this has been staged. Now I can commit it. So I can use this interface of VS Code, or I can use this thing, the interface from my command line. So I can just write git status. Here I will see this is a new file that has not yet been committed. So I can write git commit. Now, if I just do git commit, if I don't write the -m, then quotation, the string, the message, then it will automatically open my code editor. In your git config, you can configure which code editor to open by default. So here I can write some comment message, hello. I can save it, I can close it. So this change has been committed. Now here, if you click on publish branch, it can be published, but actually this is not yet connected to any GitHub repository currently. Actually I can publish over here directly because my account has been signed in. I can see that my git account is already signed in over here. So if I click publish, it will occur for me, but you need to configure your VS Code beforehand for that. So now if I see these two changes are there, so that was the basics of how to locally track files. I have covered init, status, add, commit, if all this has been covered. Now what we go is that we go on to create a GitHub account. So it's just like creating any other account. The internet is very slow here. So we go to github.com and you can create an account. Hope there will be no issue in GitHub. And internet is slow, it's not opening. Hello, am I audible? Just someone confirm please. Hello.
Yeah, Nick, you are
Okay,
audible.
okay, thanks. So here in GitHub, you can open this. GitHub has, okay, little slow. Okay, sorry. Good advice. But thing is that I listen to things at 2x. It's habituated, like I can't talk slow. Okay, fine. So here you can see the GitHub's, this UI is so good, like it's so lovely. They have done so much animations using CSS. I don't know what technologies they have used, but this is looks so pretty, so pretty. These animations are there. See the color is going. Oh, this is so beautiful. I think there's some lag in Google Meet, but if you can experiment with this github.com website, it's just a marvel of a front end. Just a marvel. So here what we have, you can see a lot of things like GitHub also provides project management tools also. So such a long page, this page features all the features of GitHub, but if we don't need all this, you can just sign up. When you click sign up, you will have this page. What a beautiful interface. When I opened my GitHub account, this kind of things were not there. I am also seeing this first time. I opened my GitHub account long ago. This kind of interface was not there. Such a pretty interface. So you can enter your email, blah blah blah, and you can just create the account. Now, once you have created your account, how you do create a new repository? First time, GitHub will prompt you to add something. Like it will ask you for what you want to use GitHub. What is your purpose? You can just click education, blah blah blah. So after that, you will get something like this kind of repository. It will be empty when you open your GitHub account. This will be empty. But see in the right, this GitHub interface has changed over the time. Earlier when I used to use GitHub, this interface was so different. Now on the right time, it's showing me some trending repositories like which have got good number of stars in recent times. This is some latest changes of some popular repositories, or maybe some repositories I have followed. This is some explore, some suggestions, some recommendation engine is there. Recently I was seeing Godot. So obviously GitHub is smart. They're recommending me some Godot project. So I use Obsidian. Maybe sometimes I have searched Obsidian maybe on GitHub. So GitHub is smart. They record what I have searched and they're showing me this thing. So here you click on the new repository thing, and let me discuss about two files. One is the .gitignore file and the just license file. Now in open source projects, what is open source? Open source means you are allowing anybody to copy, but there are some restrictions. How can a person copy? In some license, it requires that you have to give credit to the author. In some license, giving credit to author is not required. And you have to follow the licenses. When you are doing some professional work, when you are working for a company or working for a reputed thing, you should ideally follow the conventions and the ideal ways. You should not just copy code without giving credit. That's a very bad habit. And suppose someone browses your GitHub and there are automated tools to check. So someone can run a plaque check on your, everything is public. So whatever you posted on GitHub, whatever you have put on GitHub, everything is public. There exist programs to check whether those are the original work or not the original work. So if you copy, you should definitely give attribution. You should follow what the license says. There are certain licenses like GPL, General Public License. I think that's a full form. There are certain licenses that forces you to use the same license for all the derivatives of the work. For example, you're using a project, let's say project X, and let's say for example you're using some plotting library. You want to plot some graphs and you're using some plotting library, and suppose that library is using some GPL license, some license that is that now you create a project using that library. You must have to license your project under the same license. That means your project is a derivative of the original project. You are deriving your project out of the original project, and all the derivatives of the original project must have the same license. That is enforced by the GPL license. But there are more lenient licenses like MIT license that was developed in MIT, and it's much lenient. You just need to give attribution to the author. Now in GitHub, you can just look licenses. So when we are making a project, you will get this thing. You have this good documentation on choosing a license. There are so many licenses like academic free license, Apache license, blah blah blah. This is mostly of no use. Most commonly used license is MIT license. Another thing is an unlicensed. Unlicensed is very simple. Another thing is that like do what the fuck you want license. That's a very famous license. Right? F license. You can see what that comes. WTF license. Some very funny licenses there. This one, WTFPL. This is a very lenient license. Complete freedom. You can do whatever you want. That's a fun. So somebody got tired of all these names and somebody created the license. You can also create your own license. A license creating is just nothing. You just write the terms. That's it. Here is it. This is the license. WTFPL. WTFPL. So Creative Commons license is one license. The unlicensed is another license. Unlicensed is again very lenient. But most standard license is MIT license. It's most commonly used. It's just the good balance between extremes. So this is about license. You can how to put a license on your, just put a file that should have the name license, LICENSE in capital. It can be small also. GitHub will detect that, no problem. But ideally it's in capital, all caps. Now you have your we have to discuss about .gitignore. Very important thing. Suppose you have a file that you don't want to add. Let's say in my project I have this code files. Now I have a file, let's say .env, very commonly used file for storing your passwords for your project to connect to some external services. Let's say you're connecting to some API that has authentication method, some password. So I can write some pass is equal to some password is there. But I don't want this file to be public. I don't want to share this file with others. So I should not track this file in GitHub. What I should be doing is that I will be actually ignoring this. So I can create another file called .gitignore. So inside the .gitignore, I have to write what files I need to ignore. So I just write .env. So this file will be ignored. I save it. Now if I do git status, you see .gitignore is there. It's showing untracked files, but it is not tracking your .env. It's not tracking your .env. So let me see what happens when the .gitignore is removed. If I remove .gitignore, now if I do git status, now you see the .env is being shown under the list of untracked files. It is being shown the .env. But when I had put .gitignore, Git was scanning the .gitignore file and understanding what files to ignore. So if I again do this micro.git ignore, if I do this and if I write .env, if I save it, then what will happen is that you now if I run git status, it will show .gitignore only. It is not showing .env. Now if I open this repository in VS Code, you will see that this .env file, this is actually not highlighted. You see, it got like in the color convention, it got pale. It is not bright, it's pale. So in the visual manner also you can understand. So now in my .gitignore, this file is there. Now here you can put wildcards also. Suppose you want to ignore all CSV files. Let's say you can do star.csv. So star means all. So if I put any CSV file, it will be ignored. So if I add a new file, let's say hello.csv, it will be ignored. It's grayed out. And if I say what.csv, it will be grayed out. Okay. So in my gitignore, I can put this kind of things. So I can also do, I can ignore all files within a certain folder. So let's say I have a folder called rubbish. So I want to ignore everything that's within this rubbish. Now, this will be useful. I'll show you some actual project where this is useful. Let's say when you are running a project, let's say your project is generating some images in your local directory. Let's say you are making an application that is downloading some images, blah, blah, blah. You are working with other files. You are working with data files. Let's say some large data files or maybe some kind of other files that is present in your repository, but that's not a part of your code. If it's not a part of your code, you should not be committing it. There are certain files that should not be committed to the source control. That is part of your code, part of your, like, what to say, like it's part of the work, but it's not part of the actual code. You can definitely commit assets like your images, screenshots, or let's say some logos, this kind of things. These are assets. Must be committed, but certain kind of things should not be committed, like some garbage values. Let's say when I compile a C program, after compilation, the executable .out, that should not be committed. That's a standard. Use open and see any C and C++ project on GitHub. You will find that nobody commits that executables. But that is something else called GitHub releases. If you want to release the downloadable, you want to release the APK file, like the Android file APK, or in Windows .exe, in Mac.dmg, or in your Ubuntu some kind of .debian files, whatever file you want to release, you can create a release for that. You can publish those files under releases, but those should not be part of your repository. That's a convention that we need to keep in mind. So till this, what I have covered is that I think everyone can open a GitHub repository. It's very simple. Using GitHub from the web interface, I have covered some aspects of it, not fully. I've discussed .git ignore and license. What I was speaking is that I want to ignore everything within this folder. So inside the folder, let me create some file. Let's say file.c, and I want to ignore everything inside this folder. So in my .git ignore, I can just do rubbish. If I just type rubbish, it will be ignored. You see, it has been grayed out. I can just do ignore. But suppose I want to ignore all YAML files within rubbish. So if I do star.yaml, so see, this is very tricky. Very simple. Rubbish/star.yaml. It will ignore all. See, rubbish is no more ignored. Only YAML files inside rubbish will be ignored. Now, what is a YAML file? So if I do hello.yaml, YAML just stores key value pairs. So if I have some value, let's say password 123. Then let's say I have source. Let me give some name. Let's say name hello. Then you can write some name Sumit. So whatever you want, you can write. These are some key value pairs, and all programming languages have some way to parse YAML. You can parse this. Like it follows a fixed syntax. This is a human readable way to configure your program. You're making some application. It will take some parameters, some things. In Python, there's already pre-built libraries. A famous library called PyYAML. You can install that library and you can just directly parse a YAML file and instantly get in a dictionary like this key value pairs. But in other languages like C, if you're not using any external library, obviously there exists some other external libraries, but if you want, you can parse it. You can take it character by character. It has a fixed convention, like there should be this colon and then a space should be there. The space should be there, otherwise it will be an error. You see, in my VS Code, I have this linter installed. Linter means it will read the code and understand what's going on. So here in the linter, what we have, it understands if the code is right or wrong. So it's showing the underlines. If I just put a space, it will be now correct. So that is incorrect. So based on the rules of the syntax, you can parse. So you can read character by character, and when you encounter a colon, then you expect a space. If space is not there, that's error. You raise some error. After the space, the value is there. Now value can be integer. If it's purely integer, you convert it to integer. If it's some string, yeah, like that, so on. So this hello.yaml is tracked. See, this is a green. Green means it is tracked, untracked. But see, it's under the what's it? Untracked means it has not yet it has not yet been committed. It has not yet been staged. But thing is that it's green. That means it's active. It will be tracked. But if I put a YAML file inside rubbish, if I put some dot YAML, if I put, see, it's gray colored. It's gray colored, as you can see, because it's not being tracked. If you can see this from git status command also. You can use the command line also, but VS Code has become very popular. So see, the rubbish folder is tracked, but the hello.yaml, this hello.yaml outside is tracked, but inside rubbish, that som.yaml, this is not tracked, that you can see. So this is how. So this particular thing means inside a folder I want to ignore all YAML files. So I hope this is absolutely clear. You can go on more configuration. You can just Google search the syntax for this git ignore, and that will be done. Now let us talk about the next thing, that is how do I create a repository. So over here you can choose a template. So these are some templates that I have created, or some organizations I have. So you can create a repository from a template. You can convert a repository to a template for other people. For now, let's create a, like, say, tutorial repo. So this is my repository name. This is the description that I already said. It helps in the search engine optimization. You can put some description. You can put it to be private or public. So let me put it to be private. You can choose the visibility. You can add a readme file. Then automatically a readme file will be added. You can choose a git ignore template. Let's say you're doing a project in Python. So a lot of files are pre-generated by Python. Like, not pre, like, I mean generated by Python. You can ignore all those files, and you can choose a license also here. So I am choosing MIT license. Now these are some additional tools. GitHub has a marketplace of apps that can modify your code, that can help you enhance your code. For example, this bot, IMG bot, this will optimize your images. So when you upload images to your GitHub repository, it will compress those images and do a commit. So these bots can automatically work on your code. And this code curve is another famous thing. It actually tests your code for coverage, like how much code is correct or not. Like, a lot of factors are there. It will test your code, how good code you have written. Some industry standards are defined. Based on that, also you can define your own configuration. So this is some tools that you can use. You can, when you click this, they will have access to your repository. You're granting access, so they can read your code, they can modify your code. When you give the permission, they can do it. So after all this, I can, after giving my over here, I can choose the owner also. Like, I am in multiple organizations, you can see. So this is my personal organization. This is just another I created. This is some external. See, I don't have permission. I am not the admin in this organization, somebody else's organization, but I am this admin in this organization. I'm an admin. So where I'm admin, I can actually admin is like some sufficient permissions are there. I can create here. I can create here, but over here I cannot create. So that's it. So you can be part of multiple organizations. So now you can click on create repository. So when you click create repository, this repository will be created, and you can see here. Over here, by clicking on the this settings button, you can put some link, you can put some topics. This is like in YouTube you have tags, right? In anything you have like hashtag kind of things. This is like that only for the search engine optimization. So here, this is the files. So in the license file, as you can see, this is the MIT license page. So this is a copyright. Now you can edit. Suppose in your project multiple people are there, so you can put the names of all the people by comma separated. That's a standard way to write. And after that, the terms of the license are written. That's it. This is how. And this thing, this on the top, this thing, that interface that you're seeing, this MIT license, this is by GitHub. GitHub is showing the permissions, limitations, conditions. So permissions are commercial use, modification, distribution, private use, blah blah blah. Limitations is that it does not give any there is no warranty. I'm not guaranteeing that my code will work. That's the thing. The code may break at any time. When a code is published under MIT license, the creator of the code does not give any warranty. The code can malfunction also. I'm not taking any responsibility when I'm publishing it under MIT license. But see, there are service level agreements, SLAs. So when one company, let's say Google, is doing a business with another tech company, they will have some service level agreements. There Google will promise that I will provide you this, I will provide you this much uptime, I will provide you this much reliability. So if Google fails to do that, Google will have to pay. Google have to give some discount or pay. So there are service level agreements are there in proprietary projects, in commercial projects. But in case of this open source MIT license, the creator of the project does not give any warranty, does not have any liability. That's a good thing. Nobody can blame me if my code breaks, if my code does some malfunction or it damages your system. I am not to blame. And there are some conditions when you are using this project, you have to include the original license statement and you have to put the copyright notice. That's the thing. That's a condition. So when you're using somebody else's MIT licensed project, you have to follow that. Now let me go through the entire thing of this GitHub interface. Now, there's a lot of things, but as you use this, it'll make more sense. When you do actual project, it will make more sense. Without doing an actual project, GitHub does not make sense. Now issues are there when you create some. Let me go to my own personal project. I'm not advertising here, but I have it in front of me, so that's why it's more convenient for me to show. So if I show, okay, so many people created issues. I did not get time to see. 1 hour ago, someone opens an issue. So use the login with existing official desktop clients. So somebody has requested this feature. So for using this project, person need to provide the login credentials. But thing is that that person is wanting some feature, so that person can create an issue. So I can reply, I can close the issue, I can edit. As I'm the admin, I'm the owner of the repository, I can do anything. So these are issues. So there are different issues. So let's say somebody has put this issue, some error is there. So that person has described this is the issue template, describe, to reproduce, expected, blah blah. I have put the template, I have created a template, and that person has followed the template. So suspend this connection is not working in web UI. So somebody has put this. So that person is a very good person. Most people are very amateurs, but this person has put the proper system information. They have put what they are using, what system they're using, what processor they're using. This helps to debug in certain conditions. So some error is there, maybe that person has put a label bug and that person has created issue. So as I'm the owner, I can close this issue. I can do anything that I want with this issue. I can assign this issue to some person to work with. So then it becomes clear who will work on what. So this assign is function is very important. So in a large project, you have a lot of issues and there are a lot of people. To assign, the admin will assign an issue to somebody. Then it will be clear. It will show that person's name will be shown. Then it's clear, that person is working on the issue. So I will not enter that. Let that person work. When that person will finish, I'll then enter. So it will clearly demarcate the concerns of different people. Now in pull requests, what we have is that you can open a new pull request from a branch. When you create a branch, in that branch you edit some code, the code becomes different. Now you create a pull request to merge that into the original branch. Then you have the discussions tab. Here in the discussions tab, people can ask questions, question and answers. So you can upvote. This lot like Stack Overflow. Then you have the actions tab. What is GitHub Actions? GitHub Actions is a way to run some script automatically. You inside a YAML file, you configure what to run and what not to do, and it will. This is another very popular tool in the industry. There are other CI/CD tools. CI/CD stands for continuous integration, continuous development. So these things will automatically run on a condition, on a particular trigger. When I, let's say, push some code. Pushing some code means from my local machine, the code will go to GitHub. That is pushing the code. When I push a code, it will automatically run. So inside this .github folder, this name is a dot. See, I hope I'm not boring anybody. Is anyone bored? Everyone listening? A lot of people have left. Hello, am I audible?
Yeah, you are audible. And
Is it boring? Is the session boring?
no, it's great.
Okay. Hey, I need feedback from people to improve. If you don't give me feedback, then I cannot improve. Sometimes I repeat certain things unnecessarily. Sometimes I may not discuss something. So I need questions. I need feedback. That will be very beneficial for all of us. Now the point is that in this .github folder, this is again commonly used. Inside this, there is something called workflows. Now, who defined these rules? GitHub, the company GitHub, they have defined these rules. They have said us that inside your .github folder, inside your workflows folder, you write your YAML files to configure. So here I have a configuration called publish.yaml. See, you don't write everything from scratch. All these templates are available. You just need to make some small changes. So what is happening is that on this on parameter, it's describing what it will trigger. This first thing is the name. Name is just defining what name. Then on the on parameter, it's, let me increase my font size, it will be better. So on release, type published. When I publish a new release in GitHub, there is something called, path wants to one. I am not admitting any new people in between, sorry. So when it's published, publishing means just you publish. Suppose you are writing a book, you are writing some draft. After it's done, you publish. And in software, you have multiple publishing. Like you publish one version, then again you work, add new features, fix bugs, you publish another version. When you download an app or a game from something, you have new versions, right? So when they publish a new version, that goes to the users. That's the thing. Now, these are the jobs that I have defined. It will run on latest version of Ubuntu. It will use some other action. So when I put this thing action/checkout v2, this will run this action. So some configuration is defined in that, it will run that. So it's a lot like importing. It's not like include statement. In C, when you're doing include something, you're using some other person's code. In Python, when you're importing something, you're using some other person's code. But here, the uses defines that what will be used. So this, whatever is defined inside this will first be run. Then again, whatever is said inside it. So this checkout means it will just clone the GitHub repository in the local machine. In this Ubuntu machine, it will download the repository, and then it will set up Python. It will install Python. It will install the package manager. Like there are different package managers to install and all. Like you have the apt-get install you're doing. There are different package managers. In Mac, you have Brew. Similarly, for Python projects, there is a package manager called Poetry that can manage the Python version, the dependencies and all. Then I put some name. These are the different jobs. So this is, one job is a publish to PyPy. PyPy is Python package index. So if you just go Py, see, just like you have your Android Play Store, right? Google Play Store is for publishing. It's an index of all your Android apps. Similarly, in Windows, you have Microsoft Store. That's the index of all your Windows apps. Then in Mac, you have apps like that's a index. Now here, PyPy is a index of all Python projects. So you make a Python project and you publish it. You can find other people's projects. For example, I have published my TGC project here. I can find this. So if I search by my name, I can see all my projects that I've published. So these are the projects that I've published. These are very old. Now the point is that here Docker is another thing that I can discuss later now. It's not relevant for our discussion currently. So these are different files that does different things. Makefile is just, it's for ease. It's Makefile originated from C++ based projects. It's for ease of compiling the project and like automating. Instead of running all these lines several times, you just automate. I run make clean and all these lines will be run. So what does this do is that it will delete some files. It will find some files and delete them, blah, blah, blah. So these are mostly copied. Like you don't have to write everything from scratch. This is some standards in the industry. Like in a Python project, you can have these lines in order to clean up some other files that is generated. Now here, if I go to the .git ignore, here are different things that I have. For example, this is a project on Telegram. It's a Telegram bot. So when that bot runs, it generates some session file that stores the information about the session connection with Telegram. That needs to be ignored. Inside the .vs code folder, that's your VS Code configuration. If you want to configure VS Code, that's there. I don't want other people to use my configuration. This is my personal configuration. Then I have this t.ipynb. This is a Jupyter notebook. It's a notebook of Python. Like Python code, you can just write in a script and like run it. Otherwise, you can also run in a Jupyter notebook. That will be like it's a like different way of running. Just I showed that hexagon example that was being run in a Jupyter notebook. So this is for testing. Foo.bar, bar.py, blah blah. I have added this test.py, blah 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 for my personal testing. Only this top part has been added by me. These lines have been added by me, and this entire thing is a template. So this is the template provided by GitHub. Most of these files are not even required. This is a large thing. It handles any kind of Python project. This is a large list. I have not created list. The experts at GitHub, they have created list, and this is just a template that I'm using. That's it. So git ignore. I hope this is absolutely clear. We have discussed git ignore in full detail. Now next thing is that today it took a lot of time. I have covered the basic idea of Git and GitHub. I don't think it will be possible to continue today. It's already 10:37. But in the next session, like we can have just another 1 or more session, and that session we can discuss how do we create how to clone a repository. So when you have a repository, now for cloning it on your local machine, you should have the permissions. You have to authenticate via HTTPS or SSH. There are multiple authentication methods. We'll discuss how to set up that on your local machine. And once you've cloned, now you can work and you can push. Suppose you write some changes on your local machine, it's committed on your local machine, then you have to upload it to GitHub server so that it's public for others to see. So pushing and pulling, the push and pull, these two important terms there. Push means from your local machine, the code is going to the GitHub, and pulling means you're pulling the code from the remote server to your local machine. That's pulling. So this push and pull concepts are there, and then I'll discuss some guidelines on writing proper common messages, and finally we will do a project on GitHub. What you can do is that we can do a hands-on tutorial. It's an interactive. Like I will tell you to do this job, and some advanced things are there. Like you can change the Git's commit history. This little confusing, not confusing, is risky. That will affect other people. If you suddenly delete the history and you force push that, then what will happen is that on other people's computer who are using that repository, there will be issues. It will not be able to sync properly. So there are a lot of other things about, like, it's an infinite thing. GitHub is a big thing. I also, like, what I know is it's maybe 1%. But thing is that as we use projects, as we do more things, we can just Google search and we can get familiar. So I would like to end this session here, and I hope I've covered the basic idea.
Hello.
Hello, yes.
Anik, it's Kaushal.
Yeah, tell.
Just tell me the difference between GitHub and that XDA developers.
Okay. That's a good question. XDA developers is just a platform for listing. Now in GitHub you have the version control. Now in GitHub you can create. XDA developers have a lot of similar features. Yeah, that have a lot of similar features. If I just go to see, GitHub has a lot of alternatives also. GitHub is not the only thing. There is SourceForge.net. There are other platforms to track
Uh-huh.
track your bugs and pull requests. GitHub is not the only platform. GitHub is just a platform to track using the Git version control system. There are other like Bitbucket is there, GitLab is there, SourceForge.net is there, for Ubuntu PPA.net, something like that. I forgot the name. There are many other things. You can create your own Git server. Yeah, some you can like create a own Git server, a server to track. Now there are many open source Git servers also. You can download them and you can install on your server. You can maintain your own server. Many companies use their own servers. Many companies use GitHub Enterprise. In GitHub Enterprise is that they use GitHub but locally. Like they instead of using the service provided by GitHub, they use it locally. So, now
So
SourceForge.
now, if
Yeah, sorry. XDA.
that's
It's a blog also. They have a blog. They have forum. It's a big thing. Yeah. Tell.
is that something like SDA is more focused on Android?
Yeah. XDA, as far as I know, I don't know much about XDA, but I heard it's a tech community. You can say XDA is a tech community, and what they have is that they have this their homepage. From the homepage, what I'm seeing is that they have blogs. They have a forum where you can ask questions and
They
all.
have a blog.
So, but it's not a source control. It's not like GitHub. It's different. GitHub is more for version control and collaborating on a project. On GitHub, you can collaborate on a project. You can work on a project multiple people. And GitHub is the industry standard used across the world. You see any project like React or any popular, or for example, Godot. The game engine we are using Godot, right? Godot is officially in GitHub. This is the official Godot engine. You can start this repository. This is the official Godot engine. This is the code of the game engine. You can see all the code. It's open source. It's free. C++, C hash, C, GLSL, Java, blah blah blah. All these languages have been used. This is the actual Godot platform. This is the README of Godot. Okay, these are all the files. This is the Godot actually. This is the code that's running in the engine. You can see anything that you find, like 99% you will find on GitHub. GitHub is used by all companies, all projects. Some people use their own Git server for privacy. GitHub actually, there's a case going on GitHub in California. They used to train their AI models. AI can automatically write code. So this code was used. Some cases there in the code. It's still going on. A lot of companies, other companies have sued GitHub. So yeah, there will be conflicts. So yeah, that is it. So I have a lot of points to cover. I have not been able to cover those points. I have like deviated in certain times, and it took a lot of time. I think I started from 9:30 and it's 10:41. I would like to stop today, and I can continue someday else. Like obviously tomorrow. Tomorrow I'll try to be hands-on session so that everyone can download the Git and use Git on their machine. So that'll be great. So Vishwajit is there. Suban has left, and Varun has
Yeah,
left.
yeah, I'm here.
Varun already knows. He said he already knows GitHub. I do hope there is no problem, and Suban can watch the video once. Or there is enough YouTube videos. YouTube videos are more interesting. I'm just doing it first time. Like I'm doing it in a very bad way. I don't have a pen right now. I don't have animations. If you go to YouTube, you will find fantastic high quality videos. Obviously, you can go through any YouTube video. And another thing is that main thing is that you have to actually work on GitHub. If you start, you create a repository, you use the Git command. As you work, it will absolutely be clear. And obviously, there will be errors. You have to Google search in Stack Overflow. You will get articles and all. And now, obviously, recently ChatGPT is there. If you get an error, you can search there. You will get the resolution of that. So as you use it, it will get absolutely familiar and comfortable. So it's a very essential tool for the industry. There's a lot more features in GitHub, but it's a very important thing, like a very crucial and central thing of software development. A lot of things revolves around GitHub. Once you're comfortable with GitHub, then it's much easier to do everything else. Yeah. Any questions? I would like to end the session now. If anyone has any questions or any doubts or any suggestions and any feedbacks, it will be really great.
No, Nick, the session was really good.
Okay.
It was great.
Okay. So I hope I'm ending the session now.